Okay, so hey Gayatri, can everybody hear me okay? Can you guys see the board okay? Okay. Now, hey Samin, Ashley, you guys were missing in the class yesterday. I know it's summer break time, so many of you must be having some travel plans, some fun activities, but yeah. So whoever misses the class, the only thing that you have to do is watch the video of the class after the class is done, so that at least you stay on the same page, or you are able to figure out what did we learn, what did we miss. If there is some doubt, come back to me. Okay? So what are we going to learn today? Let's see who remembers. Yara. What are we going to learn today? Hear the question completely before you answer.
The 4 ways to find out two triangles congruence.
Yes. Yeah, Dikshita.
Geometry figures.
I'm sorry?
Geometry figures.
So basically, yeah, so that is what we will cover. We may not be able to cover it completely, but what we discussed yesterday was that we will talk about the 4 theorems of congruence for triangles, meaning how do you derive or come to a conclusion that two triangles are congruent, meaning they are identical, their properties are matching, their area is same, their perimeter is same, everything is same. They are exact copy of each other. So we will talk about the 4 theorems of congruence, and then once we are clear about those theorems of congruence, then we will talk about, in fact you guys should be clear by now, but I'll repeat that one more time, and then we look at how those theorems of congruence we can believe. How did that come into existence? Why we are saying that is right? Okay? We will prove that, and then we will use those concepts for deriving the area of triangle or deriving other area of different shapes like quadrilateral, rectangle, square, parallelogram, whatnot. Okay? So let's look at these cryptic terms. Yesterday I started saying that there are 4 theorems of congruence. This is again for triangles, okay? I'm not going beyond triangle right now. So there are 4 theorems of congruence which are SAS, ASA, RHS. So these are the 4 theorems of congruence. Now, some of you who have come across this in the past would be very familiar. Some of you who are hearing it for the first time, it might sound a little daunting to begin with, but we'll go through this. Again, when you talk about congruence, congruence is nothing but another way to say the word identical. Am I and Dikshita are identical? Do you guys think that I and Dikshita are identical or congruent? By any chance? Dikshita will start laughing at me immediately saying, sir, you have no hair, I have a lot. Yeah? That's the first reason for the difference. Even if I dare to say Gayatri and I are congruent because I have glasses, Gayatri also has glasses, she will say, no sir, there are a lot of other properties that is not matching. Let's not talk about congruence. Yeah? Again, one big criteria is the size of the hair. So anyways, coming back to this one. So simple terms, Adrik, Arab, Hiranya, Vasundhara, everybody, if you guys are comfortable, please keep your videos on. Otherwise, you will see me transforming into a transformer or a robot in future. If I keep looking at the screen always, not see the kids, I will turn into a robot very soon. Alright. So congruence and identical are the same words. Okay? We can use them interchangeably. Now when we are saying two triangles are congruent, are we going to take a copy of this, paste on this and always say no. Are they congruent or not? No. There is a mathematical way of doing it. I gave you guys the example of my hand being congruent. You see it from this side or see it from this side, they look the same. They are of the same size. But then, that is not the mathematical way. This is the optics part of it, where you are believing based on what you are seeing here. But there is no mathematical formula I can put around this to say, okay, hence my hands are congruent. So, these are the 4 formulas or theorems that is given or derived to say 2 triangles are congruent. Now when you break it down, S. S stands for side, A stands for angle. That's what you have to remember. Are you guys with me so far? When you say an S, that stands for side, A stands for angle. Now if you read this, it will make some more sense. When you say S, meaning if there are 2 triangles where they have 3 sides matching, meaning this side equal to this side equal to this side, and this side is equal to this side. If you have 3 sides matching, they will be congruent. They will have every other property matching, meaning their angles will match, their area will match, their perimeter will match. They will have everything matching. Digestible? Shannon, Celine, Dikshita, Hiranya, Pipli, Gayatri? Yeah?
Yes.
Okay. Vasundhara? So this is the first theorem says, and this is where I had given you guys one challenge yesterday saying that if you have 3 sides same, can you make 2 different triangles where you can find them not being exactly a copy of each other? Meaning, let's say if you have 5, 6, 8 and 10, 3 sides, that 6 centimeter, 8 centimeter, 10 centimeter. If you use 3 dimensions and try plotting triangles, can you plot 2 triangles which are different, which are not copy of each other? And I have challenged you guys saying, okay, if anybody is able to do so, you will get a $100 prize from me. You cannot do it. I mean, that's mathematically not possible. Meaning, let's say if you take this as a base, 10 centimeter. How you will make these 2 sides? You will take a protector, 6 centimeter. 6 centimeter, let's say, cuts here. Okay? And then 8 centimeter, it cuts here. You join these points, and this is a triangle. You take this as a base, cut 10 centimeter and 6 centimeter. This is another triangle. When you see this is just flipped. When you overlay this on this one by rotating it, you will see that it's a perfect fit. There is no difference. So this is technically not possible. You cannot draw 2 different triangles by using the same dimension. Even if you draw 100 triangles, they will be exact copy of each other, like A4 sheets that you see. There is no 2 A4 sheet which is different. Yeah? So this is the practical proof of that. You cannot technically do it. So this theorem that we will believe hereafter, that if you have 2 triangles where 3 sides are matching, those 2 triangles are assumed to be congruent. Is that okay? Everybody okay? Yeah? Alright. Can you guys move a little bit so that you don't have to stretch to see who is looking at me, who is not? Now, let's look at the second theorem. And guys, when we are learning about these ones, I am putting effort to make sure that you understand it to its core, how these theorems are coming to existence. But after this one, I have memorized these theorems 35 years ago. Okay? And I still remember them. So you will also end up remembering them. Yes, Advik.
But we also do
No. You cannot do angle. I will come to that, okay? There is a reason for it. So, side, angle, side. Meaning, if you have 2 triangles where 2 sides, let's say this side is equal to this one, and this side is equal to this one, and this angle is equal to this angle. Then these 2 triangles will be congruent. And why would you believe that? You will say this teacher is just forcing us to believe this. Yeah? Correct? Sarnin, Sulain, Gayatri, Hiranya, anybody? Vasundhara? I'm forcing you guys to believe this, right? Do you want to surrender and say, okay, if the teacher is saying so, let's believe it? Now, don't surrender. Now, here's the thing. I'm saying that when my this side is equal to this side is equal to this side, then this side's length is equal to this side. I'm saying so. And you will say why? Yes, Arab. Can you be a little louder? Because you are very feeble and you are speaking very fast. So you be louder and slowly speak. Speak slowly, okay?
So, what is a side and isosceles triangle?
Now, I'm not saying that this side, if this is 5 centimeter and this is 8 centimeter, I am saying that this is also 5 centimeter and this is 8 centimeter. Are these isosceles triangles? So basically I am saying that length of this side is equal to length of this side. Length of this side is equal to length of this side. I am not saying these two are same. When these two are same, then only this is isosceles triangle. Correct? You guys agree? Vasundhara, Gayatri, Sanjay, Celine, everybody with me? Okay. So I am saying that if these two, this side is equal to this side is equal to this side, then this side's length will be equal to this side. And this is hard to believe. Let's look at it. Now let's look at it. Now I'm flipping this triangle, okay? I'm flipping this triangle. Or let me make it visually better. Side angle side, any two side, okay? So I'm not picking this side, let me pick another side so that you can visualize this better. Let's say this side is equal to this side, 5 centimeter each, and this side, let's say 8 centimeter, and this is also 8 centimeter. And this angle, meaning the angle between the two sides. See, the angle is between the two sides, okay? Remember that. So whichever side you are picking, the angle between the two sides, okay? So this angle is equal to this angle, okay? Now I am saying that if this side is equal to this side is equal to this, and this angle is also same, then this side's length will be equal to this side. That's what I am trying to say. But you are saying why? Now let's look at the situation here. Let's say I am drawing a 8 centimeter and I am drawing a 5 centimeter. But let's say this angle was 80 degree, I am making this 20 degree. Now look at this side's length. This side's length is reduced, right? Because I reduced the angle. If I expand this or increase the angle, this side becomes bigger. Meaning, how big this side will be is a function of how big the angle is. Yeah? So these are two sides, right? Now we are talking about the distance between my two fingers, okay? See, the distance between my fingers is decreasing because I reduce the angle. Distance between my fingers will increase when I increase the angle. The distance between my fingers will remain the same if I keep the angle same. So this side is equal to this side. Yeah? If I, Gayatri, Vasundhara, Hiranya, are you guys with me? Yeah? Look at this. See, now visualize this, okay? These, I'm trying to figure out the distance between my two fingers, this one and this one, right? When the angle reduces, the distance reduces. When the angle increases, the distance increases. Yeah? So, if I want to keep the distance between my fingers same, I have to make sure my angle is same. Yeah? Since you see that, okay, this is copy of here, when this distance will be same only when this angle and this angle are same. Since we know that these two angles are already same, so these two distance cannot be different. Yeah? Is that relatable? Myra, you are doing something else. No. So, Sandin Singh, are you guys able to relate what I'm saying? One,
Yes.
let me give that lame example one more time. See, I'm just talking about the distance between my fingers, right? The fingers here and here. See, when I reduce the angle, meaning I bring the side closer. Meaning, when I'm reducing the angle, the distance between the fingers reduces. When I increase the angle, this distance increases. Meaning, if I want to keep the distance between both the fingers same, I have to keep the angle same. And here we are told that the angle is already same. So my distance cannot be different. Yeah? So here, I mean, if you have to prove it, you will say, okay, let's assume that this angle and this angle are not same. If they are not same, then this length will be different. But the angle are same, so this distance will be the same. Yeah? More of a correlation that we can draw here based on what you saw here, all the circles that I was doing here. Yeah, Dikshita.
So this SAS here is like the matching should be the size and one.
Angle between them. It should be the sides and the angle between them. Okay? So now, what happened? When the two sides and the angle between them were same, then this one is also same as this one. Now it relates back to this one. Since we know that if the three sides are same, they will be congruent. So from these two sides and the angle, we found that the third side is also same. Meaning this side, this side, this side, this side, this side, this side same. It relates to this theorem. Say, okay, fine. So this is the exact side scenario. They are congruent. Sandra is not looking convinced. Convinced? Okay. Gayatri, convinced? Okay. Alright. Are you convinced? Okay. So we saw that, see again, they are quite linked, okay? Once you have proved this one, you can use this and say, yeah, this relates to this one also. Now look at the third scenario. Look at the third scenario. What we are talking about? We are saying that two triangles will be congruent if the two angles, meaning let's say this angle and this angle, this angle and this angle. So this is one, this is also one, this is two, this is two. If the two angles match and the side between them, so this side is equal to this side. If these two are same, then the triangle is congruent. Okay? Now again the same thing. Look at it. When these two angles are same, this angle and this angle are same, this one is equal to this one is equal to this one. Now look at this situation. I have one line, I made, let's say, 40-degree angle here and 60-degree angle here. At this end I made a 60-degree angle, here I made a 40-degree angle. Now I made a 70-degree angle here and then 50-degree angle here. Do the sides look the same? Meaning this side and this side, do they look the same? They are not. Or let me make it more explicit and clear. I have a 5 centimeter line segment. I have another 5 centimeter line segment. Here I am drawing a 20 degree and here I am drawing a 60 degree. Okay? I am not bothered about this two sides length right now. Now I am drawing a 80 degree and drawing a 70 degree. Here it's 80 degree, here it's 70 degree. I am just drawing angle on this point. I am not bothered about the length of the sides. Okay? What do you see? When the angle is small, angle is different, the sides are different. Look at this. If I keep the same 5 centimeter, make a 90-degree angle here and join this. The base is of same length here, but my angle changing is changing the length of the sides. Yeah? Yes or no? Hiranya, Vasundhara, Adri, Karav. Yeah? Okay. So here, from this what we are interpreting is, if I have the same base but different angles, my length of these two sides are changing. Meaning, if I have the same base and same angle, then the sides will also match. Yeah? So if I have same base and same angle, they have no option to not match. Meaning this side's length will be equal to this one, this side will be equal to this one. Now again, you have these two sides matching and you found that if your angles are same, the sides are same as well. So you cannot imagine a situation where you have the same base and same angle but different sides. So the sides are again matching. So this side is equal to this one, this side is equal to this one, and this one anyways we took same. So again, three sides are matching. Again relates back to this one. So this is also equivalent to this one. So what that theorem says now is, if you have two triangles with the two angles matching and the side between them matching, they will be congruent, meaning every side matches. When the sides match, they are the same identical triangles, their area will be the same, their perimeter will be the same. Yeah? Three theorems we have seen so far, and somehow we are partly or fully convinced that yes, these theorems look okay. Do they? Niranya has been very quiet. Am I being able to convince you so far, beta? No? Vasundhara also very quiet. Have I been able to make some sense? At least 50%? Okay. Alright. So we saw three theorems, okay? Three theorems. SSS, meaning if there are two triangles where the three sides are matching, they will be congruent or identical. If we have two triangles where the two sides and the angle between them matching, they will be congruent. If you have two triangles where the two angles and the side between them matching, they will be congruent. Now what is this RHS about? RHS, R stands for right angle triangle. So this theorem is unique for right angle triangle alone. This says that if you have two right angle triangles and their hypotenuse match and one of the side matches, then they will be congruent. Now look at this. You have two right angle triangles where the hypotenuse matches. So let's say this one and this one matches. Obviously these two angles are 90 degrees. And one of the side matches. Let's say this side and this side matches. They will be congruent. Do you guys think this theorem is right? We all have one uncle that is common. His name is Pythagoras. This common uncle of ours had given one formula which says a square plus b square equal to c square, where c is the hypotenuse and here the a and b are two sides making the 90 degree angle. Now your hypotenuse are same, this and this are same. Your one side is same, so this, let's say this side and this side are same. So c square, let's say a is common, c square minus a square, and these two are same. If these two are same, no matter what, the value of b, the other side will be the same. You cannot deny that. Yeah? If you guys don't trust me, at least trust Mr. Pythagoras. What happened, Arav? You are baffled? Alright. So now all that effort we have put for last 30 minutes, 25 minutes is only to convince ourselves that when you have triangles, a pair of triangles, when you have two triangles, there are four ways, four methods that can help us to find out if they are congruent or not. These three methods are common for any and every type of triangle. This one is very unique about the right angle triangle alone. Are we all clear? I want to pick your brain. Your as in pick brain of one of you in the class. Now I want to go back to Adrik's question. Adrik had asked, can we think of a theorem which says AAA? Like we are saying that if you have two triangles with sides matching, can I say that if I have two triangles with angles matching as congruent? How many of you have your own phone or are very comfortable using any phone? Everybody, right? You guys are not living in the stone age like I used to live, right? So here's the phone. So let's do this. Let's do this. Now let's look at let me go to a photo on my phone. No, not the photo. Okay, let me shape of rectangle or shape of triangle itself. You guys see a triangle here on the screen? Kind of? Yeah? Now? Yeah? Yeah? What am I doing right now? What did I do? Made the triangle look big? What did I do? I made it look small? What did I change? Length of the sides? Right? So, yeah, what are you saying? I need to eat more almonds to become as intelligent as you are. I will always look at things in a very simple way. You guys are from next generation and much more intelligent than me, but I will still stick to keeping it simple, okay? I'm not making fun of you with that. Trust me, you guys think a lot of things together. I think one thing at a time. So let's come back to it. This is the triangle. I was saying, I zoomed out, it became like this. If I zoom in, it will become like this. What is that you see here is, this is becoming bigger or smaller. Meaning the side, this side versus this side versus this side, that is different. This side versus this side versus this side is different. This side versus this side versus this side is different. What is not changing is the angle. These three angles that you see in the top did not change. It's only the side's length became small or big. This angle and this angle did not change. They remain the same. It's only it got squeezed or it got expanded. this angle and this angle did not change. They remain the same. It just squeezed or expanded. Okay. So Advik, I know it was a long answer to a short question, but what I'm saying is, when you squeeze or expand, when you zoom in or zoom out, you don't change the angle. Your angle remains the same, but your side's length changes. That is why I will not say that I will use AAA as a theorem for congruence, because what we are seeing is, even if all my angles are same, every other property is not matching. It will be a crime if I say that area of this triangle could be same as this one, even without calculating. Just with my bare eyes, if I say that potentially the area of this triangle are same, right? So that's why I was saying that you guys can probably conclude it very quickly. I always need evidence for whatever I'm saying. I could have said, Advik, no, when you have AAA, this is a situation of similarity where we talk about ratio of sides. And that would have been a point blank answer, but I don't want to give that, because if I do so, some of you will think, okay, what are you talking about? What is similarity? And some of you may remember, some of you may not remember. That's why I'm trying to keep it as simple as possible, so that whatever we know, that or whatever we don't know, that has no bearing with our ability to understand this. Yeah? Is that clear? Alright. So, this is the thing. So, AAA will not be our possible theorem for congruence. Are we all clear now? Yeah? Are there no complaints, right? Or Arab will not say that yes, I have complained. And again, don't get me wrong, I am not here to make anybody feel good about it. Even if I'm cracking jokes, that is only to make you guys awake, keep you guys awake, so that when I'm injecting the concepts in your brain, there is a free flow. Okay? Otherwise, if I make you guys sleep, I'll be talking to the robot and I'll turn into a transformer sooner. Alright. So let's look at why did I waste so much time making you guys aware of these four theorems again, or did a repetition of what you guys already knew. Now let's look at it. I am making two triangles with the same base. Let me do a little better drawing. Let's say this is my triangle 1. And what I want to do is, I want to keep it in the boundary of. So that dotted line that you see, these are parallel lines, okay? I'm just trying to restrict the boundary of what I'm trying to draw here. I have one triangle here, let's say this is 10 centimeter. And the distance between the two parallel lines is, let's say 8 centimeter or 5 centimeter. Let me draw another triangle with the same base, 10 centimeter. But this is a right angle triangle. Okay? So both the triangles have same base, 10 centimeter, and same height also. Okay? Now, you guys will think that we know that area of a triangle is half into base into height. Okay? Everybody knows this formula, right? So, area of this triangle and area of this triangle will be same, right? Because you both have the same base and same height. Correct? But they don't look to be the same. Why we are saying that this is a generic formula for this? why are you saying that area of a triangle is half into base into height? I understand. When I have a rectangle, I join these two corners. The area of a rectangle is, let's say this is L and this is W. Area of this rectangle is length times the width, right? How did we get the area of this triangle, which is right angle triangle, as half into this? Let's go step by step. I think probably I jumped 2 steps, okay? That's a mistake. Now, you all know area of a rectangle is length into width, okay? This part is okay? I said that, or you guys already know this, area of a triangle, if I join this corner, this, let's say A, B, C and D, this is my rectangle, area of this guy is length into width. This is the area. I am saying area of this triangle, this right angle triangle is, area of triangle is half into this, right? It looks to be half of this whole rectangle's area, but why? How do you prove that? This is where you will look at these as two triangles, DAC and triangle. DAC is the one in red. I am talking about this triangle. Red one is the DAC. So let me make it red here also. And this one is blue. The second triangle is CAB. I am making this blue. Clear, right? Now I am saying area of this triangle, let's say ABC, is half of the total area. And how will that be possible when I know that this area is equal to this area, correct? Yeah? I see Sandy and Sneen are trying to decode what I am saying. Are you with me, beta? Yeah?
Yes, we just have some trouble.
Okay, alright. Now, if I can figure out that this blue area is same as this red area, then will be fine, right? If we can prove that. And we can prove that only if we know that this red triangle and this blue triangle are congruent. Okay? How we can prove that? See, look at this. This red triangle is a right angle triangle. The blue triangle is also right angle triangle, correct? Yeah? So both are right angle triangle, 90-degree triangle, right? Now, which is the hypotenuse? This diagonal AC. So AC is the hypotenuse for both of them. So that is common. And by the property of rectangle, you know that the opposite sides are same. So this side is equal to this side. So DC equal to AB. Oh, so it is applying RHS, right angle triangle. If you have hypotenuse same and one side same, between these two triangles, red and blue triangles are congruent actually. They are same. So that is how area of my blue triangle or area of my red triangle is half of the area of the rectangle. Area of my rectangle was length into width. When I am looking at this as a triangle or a right angle triangle, I will call this base and I will call this as height. But it remains the same thing. Half into this, half into base into height. So the formula for area of triangle equal to half into base into height is derived based on the theorem of congruence that we just talked about. Yeah?
What's the formula?
Half into base into height. Is it making sense? Satwik, you joined pretty late, but I'm just trying to make sure that, I mean, if I talked about the theorem of congruence that you missed, so which you would not know, so it will be difficult to relate. But in this class, as I have told you in the previous classes, that when you guys grow up, go to level 2, I will explain and prove how do you derive the area of triangle as a formula. Yeah? So summary of whatever we have taught so far is, area of a rectangle we know is length times width. If I join the two corners, that splits this into two triangles. Whether if this triangle and this triangle are same or congruent, not same, they are congruent, meaning their areas are same, then I can say area of this triangle will be half of this total area. And that is what we are trying to prove. How this area will be half of this area, because if this and this are same, meaning if these two are congruent. And we see that they are congruent actually, because this, if you look at this triangle is a right angle triangle. If you look at this triangle, this is a right angle triangle as well. This is the hypotenuse which is common for both of them, which is anyway the same. Opposite sides of rectangle are same, so this side and this side are same. If the two sides are same, applying the theorem of congruence for a right angle triangle, if in the right angle triangle the hypotenuse are same, which is same, and one of the sides is same, then they are congruent. If they are congruent, their area will be same. This area will be equal to this area. So this area will be half of the total area. That is how the area of a triangle is half of base into height. When you relate that to rectangle, that is length times width. Yeah? Is it making sense?
Yes, sir.
So area of a right angle triangle is same as the area is equal to half into length into width. Now the problem is not solved yet. Okay, understood. Right angle triangle's area is half into base into height. But what about this? I have a right angle triangle. If you ask me to find out the area of this, I will say, okay, this is my base and this is my height. If I, let's say, I draw a parallel line on this point, okay, and pick up another point, I join this. So I have a triangle ABC. I have drawn a parallel line to this line crossing A, and I pick a point D on this parallel line, join these two lines, join these 2 points. So I have two triangles, triangle ABC, which is a right angle triangle, and triangle BDC, which is not a right angle triangle. But if you go by the formula that we know, that it's base into height, height will be the same because this is between the two parallel lines. How come that is true? How come that is true? Now if you look at these two triangles, if you can find out that this black area and this blue area, this is the only part that is not common between the two triangles, okay? This part is, this red one is anyways common. Red one is anyways common between both the triangles that we are seeing here. If we can prove that these two triangles are congruent, then we'll be convinced that yes, the area of a triangle is based on base and height, no matter whether this is triangle like this or triangle like this or triangle like this. Okay? If your base is same and your top point is on the same parallel line, then your area will always be the same. And that is what we are trying to convince ourselves with. So we just made this one and we are trying to find out if these two triangles are congruent or not. Okay? I know it will sound like a loaded thing. That's why I'm not trying to force this concept on you guys right now. We talked about the 4 theorems of congruence. We tried proving them. Then we looked at how the area of a right angle triangle is derived. So that part you get understood. Now the next thing that we are going to break our head with would be, and again this is a very interesting concept that we will try proving in the next class. I'm not rushing for it today. Okay? What I'm saying is, if I have a line, let's say 5 centimeter long, and I draw a parallel line to this one. Area of this triangle is going to be same as area of this triangle also. Can you believe it? Area of this triangle will be same as area of this triangle, or area of this triangle also, or area of this triangle also. They all look so very different, but all these the area of all these triangles that you see on the board, they'll be exactly the same. Okay, and that is why this formula for area of a triangle is derived as half into base into height. Now, if you look at these triangles, all the heights are same. The height of all these triangles are same. The base is also the same. That is why this is same. But we have not proved that yet. We will prove that in the next class. Okay? I want you guys to spend sweet 20 minutes for solving this or proving this, or being convinced about the fact that area of a triangle, area of any triangle in the world, you just need to find out the base and this height. Whether this triangle is like this or this or this, it will be all the same. And that's what we'll try to find out. Okay? We'll try proving it actually. Yeah? So now, since you guys are, though I call you all kids, but you guys are not that small a kid where you have to forcefully believe whatever I say. Now I'm trying to prove everything that we know by supplementing that with enough information so that you don't have to just agree to what I say. You have to say, okay, fine, let me see, let me check, let me revalidate, let me be doubly sure that yes, whatever formula we learn, that is agreeable, and I can prove that by myself whenever I want. Yeah? Any questions? Now let me, since we have 10 more minutes, I'll probably use 5 minutes of that. So, did you guys ever think about it? Does anybody already know whatever I'm trying to cover? That area of a triangle is half into base into height, and why? Rectangle, right angle triangle part is okay, convincing, understood. How about other triangles? Yes, Arun.
So, triangle, actually, it could be a rectangle. So, we just do it so the base and the height is like those two, 1/2 times length times width. And then we're dividing it so it could be half almost square or rectangle or something that has 4 sides.
So what I would suggest is, anyways, I'm going to cover this in the next class, and you guys are having summer break, so there's not much of assignment that you guys have to deal with. No schools also, you have enough time. Can you prove that and send it to me, Arif? I want you to do it step by step, like the way I explained, right? Just send it to me, okay? And I'll just send it to me one-on-one. Why I'm saying so, because whatever we learn, right? If you are able to articulate that, if you are able to do it step by step, that boosts your confidence 5-fold at least. Okay? So, if you could send that to me, whatever I know, if I find your style better, more interesting, much more simpler to comprehend and understand, I will borrow that strategy. Okay? So that becomes beneficial for everybody else. So do that step by step, send it to me. Only to me, okay? I don't want you to send it to everybody, because then probably that might get people biased. I don't want to create any bias before I start teaching. Okay? And if I'm going to follow your approach and I will give you due credit for that. Don't worry about it. Okay? All right. So with that being said, I will let you guys go a little early. Okay? We'll meet again next Saturday. Wait for the assignments. This week's assignment will have two parts to it. One is about the things that we learned or dealt with previously, like dealing with inequality, dealing with the system of linear equations. How do we deal with let me go through the topics. I might be forgetting, and then we'll look at how do we fine. The theorem of congruence is what I will ask you guys to describe in a. So when I'm sending the assignment, I'll give you some problem, and then I'll ask you guys to write few lines about the fourth theorem of congruence. What does it mean? So just to see if you guys are able to articulate what you have learned. Okay? All right. With that being said, see you guys after a week. Wait for the assignments and the videos. All right. Bye bye. Take care. Bye bye. Yeah. That's okay.